Friends, welcome to video session. Let us learn something new today. And before starting this session, I will just remind what we have learned in the previous session. In the previous session, we have learned what actually the our subject is, that is the strength of materials. And also we have understood what force is with the different examples. And we have understood what the stress is. And in this session, let us understand what are the different types of stress. So in the first case, there are two types of stresses. Normally, there are two types of stresses. One is normal stress and another is shear stress. Students, here there's one unit that with an animation that is Newton per mm square. This is a SI unit of this is a unit of stress, Newton per mm square. So as I said, the stress is divided into, normally there are two types of stresses, that is normal stress and shear stress. Now let us understand what actually the normal stress is and shear stress is. First, let us take an example, a rectangular object, a rectangular bar. Let's find the axis for that rectangular bar. Now let us apply the load on both the sides. In this case, I am applying the tensile load, where the two forces are acting away from the object. So we call it as a tensile load. I'll take another example. Students, in this example, let us find the axis and also let us apply the load. In this case, I am applying the compressive load because the two forces are acting towards the body. So I can call that it as a compressive load. Students, one thing you need to clearly understand, clearly focus here is the load. The load is acting along the axis. In both the cases, case number one and case number two, in both the cases, the load, both the tensile load and compressive load are acting along the axis, So let's move on to the shear stress, and later I'll come back to the normal stress. In case of shear stress, in the same way, I will take a same example, a rectangular bar, and I will find the axis. In this case, I will apply a load here. In this case, I am applying a load that is tangential to the surface. So here, just you compare with the previous normal stresses and shear stress. In case of normal stress, I am applying a load along the axis. Loads are applied along the axis in case of normal stress. Whereas in case of shear stress, the loads are acted along the surface. That is tangent to the surface. So this is the major difference between normal stress and shear stress. In case of normal stress, it may be whether it may be a compressive load or tensile load, both the loads will act along the axis. Whereas in case of shear stress, the load act along the surface. So now we came to know what actually the normal stress and shear stress is with the help of a difference. Now let me understand what the case one is. This is the case number one. What actually it is, what actually we call the case number one as. So in this case, I am applying the tensile load. So I will call it as a tensile stress. Since I am applying a tensile load, so tensile stress is induced. So that is why it is an example for a tensile stress. In case number two, as I am applying the compressive load, so compressive stress is induced. So that is why it is an example for compressive stress. Anyhow, this is an example for the shear stress. Okay, students. And let me explain the same concept with the help of a simple animation. Here, students, in this first diagram, I am applying a load that is normal to the surface. The force that is represented with the help of a green color arrow mark is normal to the surface. So this is an example for the normal stress. Since I am applying a force, normal force, I am applying a force, the stress is induced. So in this case, I am applying a compressive force. So compressive stress is induced. Is an example for the normal stress. Whereas in the second case, I am applying a load along the surface. I am applying a force on the surface. The force is represented with the help of a blue color. This is an example for shear stress. Students, from this slide, it is very clear that stress is normally divided into two types. One is normal stress and shear stress. Even there are other types also. There's a thermal stress, there's a crushing stress, there's a bending stress. Okay, so normally there are two kinds of stresses, that is normal stress and shear stress. So the major difference between the two is the way the point of action of a load, or else the line of action of a load. In the normal stress, in case of normal stress, the loads are acting along the axis, whereas in case of shear, the loads are acting along the surface, that is tangential to the surface. Sometimes we call shear force as a tangential force also. So this is an extra information. Now let's move on to the next topic, that is strain is. What actually the strain is? With the help of a definition, we can clearly understand it's a ratio of change in dimension to original dimension. So what the strain is? Strain is it's a ratio of a change in dimension to original dimension. First, let us understand what actually the original dimension is and what do you mean by change in dimension. Students, just I'll give an example. First, let us take on cylindrical rod. Just I'll take a cylindrical rod I'll buy a cylindrical rod from a shop. Later, I'll measure the dimension. That means I'll measure the length of a cylindrical rod. Say, after measuring, I got the value as 10 centimeter. This 10 centimeter is called as a original dimension. Later, what I will do? Just I will apply a load on the cylindrical rod so that I will pull that cylindrical rod. Once I pull it, the length automatically gets increased. So after getting increased, once again, I will measure the length of a cylindrical rod. This time, I'll come to know the length is 15 centimeter. Earlier, it was 10 centimeter. Just say it was earlier, it was a 10 centimeter. Now, after after applying a tensile load, it final dimension, final length was 15 centimeter. So that 15 centimeter is called as a final dimension. Now just answer me, students, what will be the change in dimension? Simple, just subtract both final dimension minus original dimension. That becomes your change in dimension. That is 5 centimeter is your change in dimension. So let us understand the same topic with an example. So students, I'll take the cylindrical rod as an example. So let us measure the dimension for this cylindrical rod. The length is L. The length of a cylindrical rod is represented with the help of L. Now let us measure another dimension, that is diameter. Diameter is D. This is the diameter of a cylindrical rod. Now what I'll do is I will apply a tensile load. You can apply the compressive load also, not a problem. But in this case, I am applying tensile load of magnitude P. What happens if I apply a load? Definitely there will be certain changes in shape and size. So this is the final shape what we got after applying a load, that is represented with the help of a dotted line. Once we get the final shape, let us measure the dimensions of a final shape. So that is the length of a final shape is L plus delta L. L is nothing but, capital L is nothing but original length, plus delta is nothing but change. Delta is nothing but change. Change in what? So I have given small l, that is change in length. If I write delta L, it is nothing but change in length. If I write delta D, it is change in diameter. Simple. Students, we have measured the final length, that is L plus delta L. So on clear observation, the cylindrical rod has increased its length on both the sides, left and right. It is represented with the help of orange color arrow mark. So that I have represented as a delta. That is the change. It has happened to the original shape. In the same way, students, there is a change in diameter also. If you clearly observe, there is a change in length. Definitely, along with that, there is a change in diameter also. That change is represented with the help of a green color arrow mark that is written as delta. Students, see, original diameter is represented with the help of a D, whereas the final diameter is this much, very small one. It is represented with the as a minor diameter, small diameter. What is the change? That is represented with the help of a green color arrow mark, that is delta. So here, what is the original dimension? Here, if I take length as a reference, the original dimension will be the length. What will be the change in dimension? Delta L will be the change in dimension, that is change in length. If I take diameter as a reference, then original diameter will be D. What is the change in diameter? Delta D. It's very simple. Okay. Now let us see in terms of formula, the strain is represented with the help of alphabet E. Sometimes in some of the textbooks, it is represented with the help of epsilon. Okay. So I will take it as a E, small letter E. That is change in dimension to original dimension. And one thing you need to understand, it has no units. Why it has no units? Because in the numerator and the denominator will be having same dimensions. If I take length as a reference, in the numerator also there will be a length, and in denominator also there will be a length. So both gets cancelled, so there will be no units. So this is all about the strain. Okay, students. Now let's move on to the next slide, that is types of strains. Types of strains. Students, in this slide, let us understand what are the different types of strain. So there are normally two types of strains, that is linear or longitudinal strain, and one more lateral strain. Linear strain is represented with the help of alphabet E, whereas the lateral strain is represented, this is a lateral strain, it is represented with the help of alphabet EL. EL is nothing but a lateral strain. So students, now let us understand what actually the longitudinal strain and lateral strain is. To understand this, once again, I'll take a same example, what we have learned in the previous slide, that is a rectangle, cylindrical rod. Same concept. So I'll take a cylindrical rod of length L. Okay. This is a original length, and also the diameter is D. So this is the original diameter. Now I will apply a tensile load of magnitude P. So here you can apply compressive load also, but I will take the tensile load as an example. I'm applying a tensile load in this example. What happens if I apply a load, tensile load? Definitely its shape and size gets increased. There will be certain change in a shape and size. Okay, so this final shape is represented with the help of dotted lines. Once we get a final shape, let's measure the dimensions of a final shape. So the length of the final shape is L plus delta L, as we have studied in the previous slide. And the change in dimension is represented with the help of a delta, that is in arrow mark, orange color arrow mark. In the same way, there is a change in diameter also. The change in diameter is represented in terms of a green color arrow mark. Okay, this is what the concept we have learned in the previous slide. So students, in this slide, let us extract some information. Students, just imagine, just understand, just clearly observe here. Here, there are change in dimensions in a two axis. there is a change in dimension in x-axis, as well as there is a change in dimension in y-axis. So this is what you need to focus. Okay, so in terms of x-axis, there is a change in length. When I focus on y-axis, there is a change in diameter. In this example, in this case, if I take the changes in length, if I take changes in length as a reference, then this changes is called as a longitudinal strain. So that is what, if I take length as a reference, it becomes a longitudinal strain. So that is why I write a formula, E is equals to change in length divided by original length. Students, here one thing I will stress, what I want to stress on is, whenever, if anyone asks you the definition of a strain, I am focusing here, strain, you are supposed to tell it as a change in dimension to original dimension. Understood? You are supposed to use this word dimension, change in dimension to original dimension, when you are asked the definition of a strain. If you are asked a definition of a particular type of a strain, that is, if you are asked the definition of a particular longitudinal strain, then you are supposed to use the word length, that is the change in length divided by original length. Understood? So then formula becomes E is equals to delta L divided by L. Delta L is nothing but change in length, capital L is nothing but original length. Students, we are left out with another dimension, that is diameter. If I take diameter as a reference, then it becomes a lateral strain. So once again, the formula is EL is equals to change in diameter divided by original diameter. See students, once again, it's very clear. Whenever you are asked the definition of a strain, you are supposed to take a dimension, change in dimension to original dimension. If you are asked the particular definition, that is a lateral strain, you are supposed to take diameter as a reference. That then the definition becomes, it's a ratio of change in diameter to original diameter. Then the formula becomes EL is equals to delta D by D, where delta D is the change in diameter, D is the original diameter. So this is the type of strain is. To be very in a simplified way, just whenever you are asked about a linear strain or longitudinal strain, length will be the reference, whatever may be the shape of a object. It may be a cylindrical object or as a rectangular bar, whatever may be the object, the length is a reference for longitudinal or linear strain. Now the point is, what will be the reference for lateral strain? What will be the reference for lateral strain? Sometimes we will take a diameter in case of a cylindrical rod, and in case of rectangular bar, I will take breadth, thickness as a reference. So to avoid the confusion, what I'll say is, in case of longitudinal strain, I should take length as a reference, fix. It may be any kind of object. Length is a reference for longitudinal strain. What about lateral strain? Simple, it is other than length, other than length. If it is a diameter, you should take diameter as a reference. If it is breadth, thickness, or whatever, you should take that as a reference. That is other than length. You are not supposed to take length as a reference in case of a lateral strain. It's very simple. Okay, students, this is what the types of strain is. Students, in this slide, we have learned by taking cylindrical rod as an example. Now let us study the same concept by taking rectangular bar as an example. Okay. Okay. Let us take a rectangular bar. Let's measure the dimensions, where L is the original length of a rectangular bar. B is a breadth. I will take this as a breadth. So I will call it as a breadth. I will take it as a reference as a breadth. Then that has a thickness. This is the thickness of a rectangular bar. Now I will apply a tensile load on both the side. Once I apply tensile load, definitely there will be certain changes in shape and size. That is represented uh, as a final shape. This is a final shape, students. This is the final shape, which is represented with the help of a blue color figure. Once I get the final shape, I will measure the length of a final shape. Length will be L plus delta L. Okay. If I clearly observe, there is a change in length that is represented in terms of a orange color delta. In the same way, there is a change in breadth also that is represented in terms of a green color arrow mark with delta. In the same way, students, there will be certain changes in thickness also. Here it is not represented, but there will be certain changes in thickness also. Whenever you apply a load, there will be certain changes in all the dimensions. Okay. So let's move on to the types of a strain. As I said, whenever you are asked to define strain, you are supposed to use the dimension as a keyword, change in dimension to original dimension. Now I ask you a particular type of strain, longitudinal strain. So in the previous slide, I have explained you, in case of a longitudinal, you are supposed to take length as a reference for any kind of an object. So the formula becomes E is equals to change in length divided by original length. The formula is E is equals to delta L by L. Okay, it's very clear. Now let's move on to the lateral strain. This is a lateral strain. So the formula becomes EL is equals to change in breadth or thickness divided by original breadth or thickness. Students, it's very clear what I said. You are supposed to take dimensions that are other than length. Just observe what are the dimensions that are other than length. It's breadth and thickness, very simple. So that is why I have taken breadth and thickness as a reference. So next, I will simplify further. That is EL is equals to delta B by B. So that is nothing but delta B is nothing but change in breadth divided by original breadth, or change in thickness divided by original thickness. That is EL equals to delta T by T. It's very simple. This is an example for the types of strain. In the previous slide, I have explained you the same concept types of strain by taking cylindrical rod as an example. In this case, I have explained you with an example of a rectangular bar. This is all about your types of strains.